In the last video, we looked at doing a binomial test for a population proportion, and in this video I'm going to cover using confidence intervals instead to tell us more about our beliefs about a population proportion. So we're going to use data on turtles, so I'll read that in and we can take a look at it, and then we can summarize our data as follows. So it looks like we've got 131 females and 38 males in our sample, and we're going to use this information to estimate the proportion of females in the population. So the numbers we need are the sample size, so that's 169 in this case. So that's the sum of 131 and 38. And then our value of x is going to be the number of females. So x is 131, and then our estimate is going to be the ratio of x over n. So we'll call that p hat, and p hat comes to 0.775. And so we have the usual statistical inference idea going on here. We've taken a sample from a population, and so we're estimating the proportion of female turtles in the population, but we know that there's some uncertainty that we need to account for in our sampling when we report that number. So one way of addressing that is to do a hypothesis test, as we covered in the last video, and another way is to calculate a confidence interval. So to calculate a confidence confidence intervals usually have the form estimate plus or minus a margin of error. And in this case, the estimate is the p hat, and then the margin of error is going to be a percentile from an appropriate probability distribution times a standard error. So first of all, let's figure out what the standard error of the proportion is. So it's given by this formula here. So the square root of p hat times 1 minus p hat over n, and that comes to 0.032. And then the method that is recommended in the book to calculate the confidence interval is something called the Agresti-Cool method. And so if we're doing the calculation for a 95% confidence interval, we actually have as the center of our interval not p hat, but something called p prime, which is actually the ratio of x plus 2 over n plus 4. So we can calculate that. So that comes to 0.7688. And then the percentile from a probability distribution, in this case it's a normal distribution, and because we're doing a 95% confidence interval, we're going to have 2.5% on either end, and so the percentile that we need is the 97.5th percentile. So we can calculate that using this qnorm function. So that's the 1.96, that should be a familiar number. And then we calculate the interval as the estimate plus or minus the margin of error, where the margin of error is that percentile times the standard error. So I'll do those two calculations. So we get a 95% confidence interval using the Agresti-Cool method, going from 0.706 up to 0.832. So we can say we're 95% confident based on this sample data that the population proportion of females is in the interval 0.706 up to 0.832. Alternatively, there's a built-in function in R called binom.confint. So we can take a look at that to get more information. Okay, and it's telling me it can't find it. So this is good that this happened, because I can show you what to do if this kind of thing happens. So if it doesn't find the function right away, you can look down here, and it'll maybe give you some links to try down here. And in particular, it's telling you this first piece of this link here is telling you that it's the package binom that I need. So I forgot to load that package. So let me use the library function to load the package, and then I'll type this in again here, and it should find it this time. So yeah, sure enough, there it is. So here's information about that function. And then now I can use that function. So the arguments are the number of successes. A success in this case is a turtle being female, and is the sample size. And then there's different methods. You can see here these different methods that we can use to calculate the interval. There's all these different methods that are programmed in. We're going to use this one here, AC, standing for agrees to cool. So if we run that, you'll see that our interval, it's actually a little different to the one that we calculated by hand. And that's because the method that R uses is ever so slightly different, so the results don't match exactly. But they're very, very close. So that's how to use R to calculate a confidence interval for a population proportion using the binomial distribution.